Welcome back for more AP Calculus. This time we're looking at free response type questions from the Chapter 5 practice test, applications of derivatives. So if you're ready for this, I'm ready for this. Let's get going with some calculus. So consider the equation gt equals 1/4 t cubed plus 16 over t, where t is time in minutes. Part A. Let g of t be y is g of t. And at t equals 6, evaluate the differential dy for a dt equal to negative 0.5. Okay, well, that's really mostly a derivative question. Dy dt is going to be equal to the derivative of y, of course. And the equation for y is going to be 1/4 t cubed plus 16 on t. And we can take our derivative. That's a pretty easy one. This derivative is 3/4 of t squared minus 16 on t squared also. So we got to evaluate this, the differential when dt is negative 0.5. So this says that, let's simplify that a little bit more. That means dy is equal to 3/4 of t squared minus 16 on t squared multiplied by dt. So we're multiplying that dt across to the other side here. Next, we can just substitute our values of t and our value of dt. So that gives us 3/4 of 6 squared minus 16 on 6 squared multiplied by a dt of negative 0.5. And if you don't know where that 6 came from, that's right over here. No, right over here. All right, that's just a matter of calculation. So when you calculate that, you get dy is equal to negative 13.27777. Part B, we use a tangent line approximation to approximate, or at t equals 6, again, that's also important, to estimate g of 5.3. So let's talk about what a tangent line equation looks like in calculus. In calculus, a tangent line, and this is just the same thing as the point-slope form of the line, you would get y equals y naught plus m x minus x naught. In terms of calculus, that's going to be equal to f of x naught plus f prime of x naught for the slope, and then x minus x naught. Well, we don't have x's, we have t's. So that means our tangent line equation would be y, and this is now going to be an approximation. That's going to be f of t naught. Oh, nope, sorry, not f, we have g. G of t naught plus g prime of t naught multiplied by t minus t naught. And of course, t naught equals 6. So even more to this, we're going to get y is approximately equal to g of 6 plus g prime of 6 multiplied by t minus 6. So let's calculate a few things. The first thing to calculate is g of 6. G of 6 is equal to 1/4 of 6 cubed plus 16 on 6, and that's equal to 56.66666, 56 2/3 really. The next thing to calculate is g prime of 6, and that's equal to, good thing for us, we evaluated g prime. G prime is 3/4 of 6 squared minus 16 on 6 squared, which is equal to 25.5555, which is what, 25 and 5/9. Be careful here. Sometimes students want to put this value in for g prime of 6. And remember, that's not g prime of 6. That's just dy, the differential, not g prime of 6. So although they are related, they are not the same thing. So don't substitute it. Well, with those two values, we can now substitute things into our equation for the tangent line. So we have a tangent line is equal to, and y is approximately equal to 56.666 plus 25.55555 t minus 6. Great. And if that's our tangent line equation, now we can estimate g of 5.3. So g of 5.3 is approximately equal to 56 and 2/3 plus 59 and 25 and 5/9 multiplied by 5.3 minus 6. I kind of got tired of writing all of those repeating decimals. This is now just calculation. So put this in your TI and you get g of 5.3 is approximately equal to 38.07777. And lastly, we're going to use the second derivative to explain why we got an under approximation here. So for part C, let's remember that if the second derivative is less than 0, that means that we have a concave down function. So either a function like that, a function like that. That's a concave down function. And notice what happens when you use a tangent line approximation to a concave down function. No matter where you draw your tangent line is above the curve. So this means that concave down, a linear approximation is over approximation. Similarly, if we take a look at a concave up function, the linear approximation is an under approximation for a concave down function. Well, what does that say about our g double prime? Well, if g prime was equal to, and you'll have to forgive me, I'll go up there and I'll grab that function. If g prime is equal to, where is g prime? Yeah, there it is. 3/4 t squared minus 16 over t squared. If that's g prime at the point of tangency, and I'm going to make sure I write that down, point of tangency was 6. Well, that's equal to 3/4 of 6 squared minus 16 on 6 squared. It's a point of tangency again. Well, what do we get? We get 239 over 9, which is greater than 0. So now I think we're ready. We have a concave up function, which means that our tangent line approximation is an under approximation. Since g is concave up at the point of tangency, the linear approximation of g 5.3 is an under approximation. So that's it for our first free response problem, and we'll see you next time for more of this calculus stuff. See you next time.